thank you all for joining us on the EPIC Online meeting. So I'm Guyonnet, in charge of sales and marketing at SEDI-ATI, and I'm here with Julien, who is our technical sales engineer. And so briefly, we will quickly present SEDI-ATI for those that does not know each other already. So we are a French company providing some fiber optics component based on fiber and to bring light into complex and extreme environmental constraints. We are about 60 people right now, and we have made last year 8 million euro turnover with an annual growth of 10%. And we expect to reach 10 million euro in 2026. We have among this turnover about 35% dedicated to export sales, mainly in Europe, due to the fact we deal with custom design and we have to be as close as possible to our customer. We have 2,022 square meter facility here in France. So we are located in the south suburb of Paris, with 4 clean rooms and 8 people dedicated to R&D. So it's growing people since we were in 2020, at the beginning of 2023, we are more about 50 people. So it's this year 10 people more. Next one. So we address different type of application from military and aerospace, sorry, energy, research, industry, medical. From that, we address different kind of environment such as high temperature, low temperature, pressure, vacuum, radiation, and so on. I think this will be on the next slide. And for product and solution, we would say we should say that we have like technology portfolio rather than product portfolio, but divided in 6 type of application. We have component, multimode component. We have disposable probes, the product that we will present dedicated to the topic of today. We have hermetic feed-through, bundles and array, and specific patch cords for harsh environmental constraint, and disposable probes for medical application. What we call harsh or extreme environment, it comes from high temperature to low temperature, for instance, in quantum computing, for example. We have extreme pressure, ultra vacuum, corrosive, radiation, and it can be also vibration or mechanical shocks. So if we come, just to come back, we don't draw fiber. We use different fiber from several manufacturers, but we handle here at SEDI-ATI more than 100 reference on stock, which allow us to be very reactive on prototype and with a very wide proposal from low UV to large infrared, and also with very custom fiber such as fiber with metal coated metal coating jacket, and also sapphire or chalcogenu or whatever. So if we come back to the presentation of today, which is linked to sea exploration and oceanography, we wanted to present our fiber optics solution, which is a disposable spool dedicated to a wire guide vehicle, which can be used for sea exploration and oceanography. So next. So just to explain how it works traditionally, you have the remote operative vehicle, which is a ROVs for marine exploration, which is connected to the surface vessel by an umbilical electro-optical cable. Sorry, I just want to... Comment on peut bouger ça quelque part? Voilà. So this cable is deployed from a winch and is electrically powered. And we use fiber for the data transfer for the HD camera or other sensor, which requires a large network. And in this case, fiber optic technology is a good usage for that application. From this, there are some constraints due to this umbilical cable, which support the vessel, and it means that it needs to be strong enough to allow the machine to be launched into the water and recovered in the event of a problem. It's also a restriction in terms of length because it's a AV cable. And it's also very difficult to go in very narrow space where, for instance, if you want to have some information on a vessel and you need to go in very narrow space, this kind of design is not very suitable. So sorry, I went too fast. Also, this cable behaves like a leash, so means that it gives you some constraint to monitor the robots. You need to have a penetrator. You need to have a traverse winding. You need to have an electrical optical rotary joint. So it's very costly and AV solution. And so, as I told you, very unsuitable for exploring shipwrecks or sea caves. So in this case, that's where SEDI-ATI solutions becomes a very interesting solution. First of all, it's a disposable solution, which is bidirectional in terms of link, and dedicated to autonomous robot vehicle, which is AUV. In this case, you have the secure and fast deployment because the fiber is linked directly on the robot. You can go up to 10 kilometers and more on request. It's a very compact solution, low weight solution, and with custom configuration also packaging. We can also have a venting hole if you need to have something very comment dire, to go deeper in water. So, for instance, to work like this, you have first of all the parent robot, which is going down. We took the experience of E-framer robot, which is the Victor 6000. So you carry the mini rov with this robot, which is equipped, which is assembled with the disposable probe. And then this autonomous robot can go and explore on the shipwreck with this solution of fiber. Sorry. And then, I think I forgot something. Sorry. No. So you have a real-time transmission for the data on board with high resolution for the camera and sensor. And you can allow the drone guidance in the deep water. You have also to keep in mind that this is very good for deployment of high-speed deployment and over a long distance, up to 10 kilometers, which is not the case with the umbilical cable, which is used traditionally. And it's also a solution with the fiber. When the mission is finished, you just have to cut the fiber. The fiber is silica, so is no pollution under the sea with this approach. So it's a very, very promising and growing solution in this kind of application. For this, to remote from the robot and the control station, this will need to be equipped with an optoelectronic device, and this is not part of SEDI-ATI proposal. We just remain on the passive link of this solution, but we work with drone manufacturer for this part. So what we do, we find the best solution for your underwater application. We have also some solution of fiber optics hermetic feed-through for pressure. So we can add to this solution some fiber optics feed-through solution. And we develop assembly to handle both the underwater constraint, but also your constraint. And the challenge are yours. And if you have any question on this, please feel free to ask.